The last kind of process is an adiabatic process. We have kept the special process for the last because in adiabatic process, the total exchange of heat energy with the system is zero. That is, heat is neither absorbed by the gas nor released by the gas. So what can we infer from the first law of thermodynamics, or what happens to the first law of thermodynamics? Delta Q is delta U plus W, or delta U equals to minus of W. That means whatever the work the gas does is generally derived from the internal energy of the gas. Or if at all we do some work on the gas, the entire work will be stored only in the form of internal energy of a gas, right? So in case of adiabatic process, the relation between pressure and volume is given by PV power gamma is constant, where gamma is the ratio of the molar specific heat capacities of the gas, that is Cp by Cv, right? Now, based on this, we'll try to find the relationship between volume and temperature and pressure and temperature. Remember, even though it is an adiabatic process, it is still dealing with an ideal gas. As long as it deals with ideal gas, it should always follow the relation PV equals to nRT. Substituting P over here, we get nRT by V into V power gamma is constant, or TV power gamma minus 1 is constant. Or the same thing can also be replaced with P into V power gamma is nRT by P power gamma is constant, or T power gamma into P power 1 minus gamma is constant. Right? These are the relationships between PV, TV, and PT. Right? The next part in adiabatic process is what is the work done? Work done formula is P into dV, but pressure is some constant. Let's call this constant as K. K by V power gamma into dV, integral from V1 to V2. That is K into V power minus gamma dV. That is K into V power 1 minus gamma by 1 minus gamma from V1 to V2, right? So it becomes K times of V2 power 1 minus gamma minus V1 power 1 minus gamma by 1 minus gamma. Or it can also be written as K by 1 minus gamma into, this can be written as V2 by V2 power gamma minus V1 by V1 power gamma. Isn't it? Or it can also be written as K by gamma minus 1 into K by gamma minus 1 into P1 V1 minus P2 V2, because P1 V1 power gamma is equal to P2 V2 power gamma, which is equal to constant, that is K. Based on this, I can write down this relation. That is K by gamma minus 1 into P1 V1 minus P2 V2, which can also be written as, sorry, there is no K over here. P1 V1 can also be written as NR T1 minus T2 by gamma minus 1. These are the different formulas that we can use in case of an adiabatic process. Right? Only thing that we have to understand or remember in adiabatic process is there is no exchange of heat energy with the system and the surroundings. Right? Now we'll try to compare adiabatic process and an isothermal process. Okay. In an isothermal process, PV is constant. In an adiabatic process, PV power gamma is constant. Remember, gamma is always greater than. What is the slope of this PV curve at any point? That is PdV plus VdP is 0, or PdV equals to minus of VdP. We just took derivative, right? And it is a PV curve. So volume is on x-axis, pressure is on y-axis. Slope is nothing but dP by dV. dP by dV is given by minus of P by V, which is dP by dV. This is in case of an isothermal. In case of adiabatic, it is P into gamma into V power gamma minus 1 plus V power gamma into P dP is equal to 0. Over here we have dP. Therefore, minus P gamma V power gamma minus 1 into dV is V power gamma dP. V power gamma gets cancelled, or dP by dV is minus gamma of P by V, or it can also be written as minus gamma of slope of isothermal process. Slope of adiabatic process is minus gamma times the slope of an isothermal process. What is the meaning or significance of this? So in a PV curve, when you try to draw the two processes, let's say it is an expansion from the same point. If isothermal process is like this, then adiabatic process would be like this. Why? The slope of adiabatic process is more when compared to an isothermal process. So this becomes isothermal, this becomes adiabatic. This is the relationship between the slopes in case of an isothermal and adiabatic process. Now we'll try to draw all the different processes in one single graph for a better understanding. Right. Starting with isobaric process. Isobaric means pressure is constant. First one is isobaric. Right. Now it is isothermal process. Second one. And then we have adiabatic process. Third one. And then we have isochoric process. Fourth one. Second one represents isothermal. Third one represents adiabatic. Fourth one represents isochoric. Right? These are the, like comparisons between different processes in a PV curve. The same thing can be done for compression of the gas that you can write on your own. All right.